All right, let's dive into 802.1q trunks. Each trunk line has what we call a native VLAN. Picture it as the no cover charge entrance at a club. Traffic on this VLAN slips through without needing a tag, while every other VLAN has to flash its 802.1q tag, like showing an ID to get in. The native VLAN sticks around for those older devices that don't quite get the whole tagging thing. But here's where it gets tricky. This opens the door for a security issue called VLAN hopping. Knowing how the native VLAN operates, how to adjust it, and what happens if it's not in sync is absolutely key for the CCNA exam. Think of it like knowing the capital of a country. It's definitely going to come up. Let's dive into the native VLAN. Picture it like that one guest at a party who doesn't need a name tag. On a trunk port, the native VLAN is the default where frames travel without an 802.1q tag. Usually this is VLAN 1. Now imagine a device connects to this trunk port, like a guest arriving without a name tag. The switch thinks, you belong with the native VLAN group, and assigns it accordingly. But what happens when there's a native VLAN mix-up? Think of it as a classic misunderstanding. Imagine two party hosts, each setting up a different room for untagged guests. One puts them in room 1, the other in room 99. Guests get lost, end up in the wrong room, and chaos ensues. Similarly, if two switches at either end of a trunk have different native VLANs, VLAN 1 on one side and VLAN 99 on the other, you end up with traffic going to the wrong place. It's like mailing a letter to the wrong address. But fear not, CDP, your trusty network guardian will catch this blunder and warn you. This isn't just a simple mix-up. It opens the door to potential VLAN hopping attacks. So it's a common pitfall, but now you know what to watch for. Keep your VLANs straight and your network will hum along like a perfectly organized party. To change the native VLAN, you'll want to use the command switch port trunk native VLAN on every trunk interface you're dealing with. Then head into global configuration mode and apply VLAN.1q tag native. What you're doing here is tagging the native VLAN traffic, essentially giving each data packet a name tag so there's no mix-up about where it belongs. When you tag this traffic, any mismatches between devices result in frames getting dropped, rather than accidentally heading down the wrong path. It's like having a safety net that ensures mistakes don't spiral out of control. And if the endpoints aren't seeing eye to eye, you'll get a heads up with CDP native VLAN mismatch warnings. It's networking's way of tapping you on the shoulder to say, hey, something's not quite right here. Let's dive into the 4 classic pitfalls with native VLANs. First, native VLANs are untagged by default. So when an untagged frame arrives on a trunk port, it's like it has a free pass straight to the native VLAN. Next, a native VLAN mismatch is more like a confusing detour than a roadblock. The link stays active, the lights are still flashing, but the traffic might end up in the wrong place. It's one of those mistakes that quietly lurks in the background, not demanding attention right away. Now, let's talk about the notorious VLAN hopping with a double tagging attack. Imagine an attacker sitting in the native VLAN, sending a frame with 2 802.1q tags. The first switch peels off the outer tag that matches the native VLAN, allowing the inner tag to sneak the attacker's data through. To put an end to this kind of mischief, you can use the VLAN.1q tag native command. This way, even native VLAN traffic gets tagged, and just like that, you've got it under control. And that's the scoop on the native VLAN. Untagged traffic on trunks, the chaos if things don't match up, and keeping VLAN hopping at bay. Ready for more CCNA brain teasers? Head over to Courseiva.com and keep those skills razor sharp.